design a machine learning system to recommend artists on Spotify. Okay, thank you so much, Sid, for being here. We're really excited to have you. Can you introduce yourself quickly for our viewers?
Yeah, I'm excited to be here. Hi, everyone. My name is Sid. I'm currently a senior machine learning engineer at FanDuel. And I spend a lot of my time building out complex systems in ML and excited to be here.
Okay, awesome. It'll be really interesting to see some of the wisdom that you have about like the end-to-end system of building an
Yeah,
ML system. So, all right. So let's get right into our question. So, question today is design a machine learning system to recommend artists on Spotify.
the first thing I want to know is kind of understand, is there a metric that we're using here to sort of measure the success or failure of this recommender? Generally, when I think about metric, I'm thinking about things like impressions, click rate, engagement, things like that. Is there something we're focusing on?
Yeah, let's start with engagement for now.
Awesome. Okay, so engagement, how are we defining that? Is it usually just users kind of clicking on things, or
Mhm.
what more are we doing here to gauge the engagement?
Yeah, so let's start with just the user clicking on a recommendation. Of course, like as you mentioned, you can definitely go deeper than that. But I think for now, we can say that it's a positive recommendation if the user clicked on it, and if not, that it's not considered to be a good recommendation.
Okay, great. So first things first is what kind of raw data do we have access to? Do we need to collect any extra data? Do we need to think about that within our system?
Yeah, it's a really good question. I mean, I feel like this is such a crucial part of building a machine learning system, right? Your algorithm is only as good as your data. So you have two main sources of data. The first one is going to be the click data. So that's, engagement, as we mentioned earlier. And the other is going to be metadata about your users. So that's going to be things like gender, age group, location, and like previous history.
Awesome. And then now that we kind of have a rough idea of the data, I'm really interested to also understand the raw conditions of the data that we're working with, kind of, thinking along the lines of how much data massaging we need to do to clean it up and sort of make it edible for our model to consume and start working with it. Um,
Mhm.
initially, just kind of thinking about transformations that I would have to do to get it into that format. Do we have any idea on that?
Yeah, so the click data comes in as like a raw stream of basically just JSON objects.
Hmm.
So every time there's an event, which is a user clicking, that JSON object is stored in an object store.
Hmm. Got it.
And then for the user data, that's a little bit simpler. We just store that in a Postgres account table. It is PII data though, so that's something to be careful about.
Got it. Okay. So, from my understanding, I'm just going to kind of summarize so far what we're looking at. So, we're looking at engagement as a metric
Mhm.
to gauge the success rate of our recommender. Our
Yep.
goal is to be able to successfully recommend either artists or songs on Spotify.
Mhm.
And then the data we're working with, we essentially have two different sources. One is
Mhm.
the click data that we're getting in JSON format. So, this is usually streams data that's coming in whenever someone clicks on things. And
Yep.
then the second thing we're looking at is user data. So that's usually things like metadata about the user, their
Mhm.
ID, their, I guess, email address, but I'm not expecting us to use that, but age,
Mhm.
location, things like that. Um, so I'm trying to see in my head how we can kind of like join these together and get them in the right format to serve essentially as our features for our model.
Mhm.
But we'll get to that bit after we get into a little bit more deeper.
Yeah,
Um,
that's a good
so
summary. Yeah.
Awesome. Sounds great.
Mhm.
So ideally, what we're trying to do here is figure out how we can take these 2 points to
Mhm.
create our initial data processing pipeline, and then fetch what we need to do to
Mhm.
create our features. Um, and then the next question that I had, which I wanted to understand a little bit better, is: are we doing these recommendations in real time or batch? What's the cadence there?
So I think you might need to be a little bit more clear about that. But essentially, you need to recommend artists as soon as the user logs in because they're immediately presented with the recommendations.
Got it. Yeah, so I can clarify a little bit. I guess what I meant was if a user logs in, of course, we're gonna give them the recommendations that are more personalized to them. What I was trying to understand is from the model training standpoint, model testing standpoint, and even the inference generation standpoint, Are we looking at doing all of that in batch or in real time? And I'll explain a little bit behind my thought process as to why I want to kind of analyze that a bit better. From an overhead standpoint, from a compute, storage, and all the technical standpoint, a batch-based system is generally easier to manage. You're not necessarily doing a lot of compute-intensive stuff in real time within, a less than a second or anything like that, and sending it over. Of course, we can do it, but the idea here is to make sure that we try to reduce that kind of technical complexity if we have to. My understanding here is we could do everything in batch, the training and the inferencing, or we can do part in batch. We can do the training in batch and then the actual inferencing in real time, or we can do everything in real time as well. So everything is possible. The best way I think I would attack this is kind of think along the lines of how is our accuracy of the recommendations that we're generating? How would that change in each case scenario? Because if we're able to achieve the accuracy metric that we set out by doing all in batch, that's great, right? We don't have to do too much technical work, and we're getting really good, accuracy, and that can kind of, on a very high level, be our first iteration that we look at. And then once we sort of get accuracy metrics there, then we can see, can we make this a little bit better? And we can talk a little bit more towards the end about sort of doing further iterations on our base model, right? Where we can go on to thinking about building models that might be part real time, part batch, and then eventually a full time, full real time model, similar to how like TikTok's recommendation system works. But I'm thinking for now, best solution might be to look at a full batch based solution, since we really don't have full idea of what our accuracy is going to look like. How does that sound?
Yeah. Yeah, that sounds great. I like that you also mentioned that we can adjust later on and see just like what the trade-offs are there with accuracy versus latency. Okay, so that being said, can you tell me a little bit more about how you plan on designing your data pipelines and what features you're going to need? How are you planning on designing them yourself?
Yeah, so I'm going to assume that I have to design them myself. I'll kind of give a high level, at least understanding of how I would go about doing this. I'm also going to assume that the system that's already firing off the events and sending the events to me, the JSON click data that is, that system's maintained by another team. All I have to do is essentially subscribe to those events. Maybe it's a event-based system of some sort. So I'll basically subscribe to that and then essentially fetch that data, dump it into a raw source, maybe an object storage system, and then I'll essentially set up a pipeline, right, that I can essentially connect to that raw source, pull that data, and then apply certain transformations on it to extract the fields that I need, normalize anything that I need to, and I'll go into a little bit more detail about what I mean specifically there. So on a high level, I'm thinking that's kind of how my pipeline is going to be. And then as this data is sort of flowing in, I'm going to join that data once it's normalized and processed with the user data that we have in the Postgres table that you mentioned earlier. So that way, eventually we have a full feature vector that says, here's the user, this is their age group, this is their, historical data on the artists that they've liked in the past, the songs that they've liked in the past, where they're located, all of that good stuff. And once we have all of that, then we can sort of normalize it. And so have that data sort of ready for our model to consume from and kind of go from there. Any questions so far? Does that kind of sound about the right track there?
Yeah, I like the level of detail there. I was curious though what you mean by normalizing.
hmm Yeah, so generally, I guess in machine learning, when we think about normalizing, it's usually trying to get to do comparisons out from an apples to apples standpoint.
Right.
So if we think about things like location or gender or even timestamps, for example, a very important field in almost all of feature engineering, right? We want to see how our data evolves over time. So let's say if we get data that's coming in from, Britain, and they'll be at a different timestamp, and data that might be coming from America might be in a different time zone or a different timestamp. How do we sort of get on the same page there, right? When we're doing our evaluations, we want to make sure we're looking at essentially the same standard of time. So
Okay.
you do normalization there to ensure that we're maybe in GMT time, or maybe we're using the epoch source sequence numbers. There's different ways of doing it, but a lot of that kind of processing will essentially take place in our data processing step.
Gotcha. Okay. What about normalizing? Like, some users might just in general click on things more often because they happen to be more active on
Hmm.
Spotify. Can you suggest like some way of normalizing for that?
Yeah, so we're thinking about here, okay, active users, active clicks. So is the idea here to look at the number of clicks per user? Is that what we're looking at here, or is it something different?
Yeah, because our raw click data, right, is literally just you get one JSON record per click. But
Hmm.
just because a user has clicked on a particular recommendation, they may be a user that they're like a power user, so they're clicking things like they're like really active, or they log in every single day. Versus you might have somebody who only logs in like once a week. So
Mm.
how might you normalize the number of clicks to account for like the general frequency of logins or activity?
Yeah. I think the best way probably is to, right off the top of my head, the way I would probably approach this is to take maybe the number of clicks a user has per 100 or per 200 recommendations, right? So that's one way of looking at it. If you have users that are kind of similar and we're, let's say, recommending the same song to or same artist to a particular amount of users, we could kind of see if one user clicked on it versus the other, and based on that, kind of see what the interaction level there might be. I would think from a normalization standpoint, those will probably be like the two best ways to like kind of look at it. I think the former would probably be the best bet here because you are kind of looking at, you're essentially providing the same recommendations to two different users, and provided the same amount of recommendations, the same kind of recommendations, you're kind of looking at which user clicked on what, and how many times a user might have engaged with what item that we're recommending, if that sort of makes
Yeah.
sense.
Yeah, that makes sense. I might also mention like, um, yeah, if you could compare that user to themselves. Like if they click certain recommendations much more than others, or you can like
Hmm.
divide by the total number of like
Hmm.
clicks that they have and so on. Yeah,
Hmm.
makes a lot of sense. Okay, cool. So let's move on. So you mentioned normalizing the data. So what do you want to do after that?
Yeah. So once the data is kind of normalized, and then I'm assuming the cleanup part is also completed. Um,
Hmm.
I did mention earlier about PII, right? I think you also mentioned that PII is a pretty critical piece of all of this. So we're
Hmm.
looking at the higher level architecture and higher level system.
Yeah.
You want to try to ward off of using PII as much as possible because just dealing with it tends to have a lot more restrictions. In our case, the two things that we're looking at that are kind of more PII related are, a user's location and a user's age.
Hmm.
So my idea is essentially to take a user's age and then categorize them into an age group.
Hmm.
Because from a research standpoint, generally age group gives a good understanding of what a user's tendencies tend to be or what they would be
Yeah.
interested in, especially in
Hmm.
something like music, right? That's like a good assumption to sort of make. And so if you put someone in an age group, you don't necessarily have to worry about what I would do with that PII. But worst case scenario, you do have to deal with PII. You can do masking algorithms and hashing and things like that to ensure that that PII remains not in plain text, essentially. Generally, location data comes in the form of coordinates. So trying
Oh.
to convert that to a city and a state would be like a good start there as well.
Mhm.
And then the other two most important things, right, is thinking about, in our case, we want to recommend artists for users to like click into and follow. And then we also want to recommend songs that we want users to click into and follow, right?
Mhm.
And so in those scenarios, we're essentially thinking about for each user an array of the most recent 100 songs that they've listened to, and
Mhm.
an array of the most recent artists that they've followed.
Mhm.
And array essentially contains map objects of all of these artists, right? And this could be things
Mhm.
like artist name, their most important songs that have come out, the number of days they've been active on Spotify, their
Mhm.
trending rank amongst their competitors, number of followers, all sorts of stuff. And then for songs, similar things. But one of the interesting two things that I can think about is the average listen time for that song compared to how long a particular user we're looking at is listening to that same song. So, for
Yeah.
example, let's say I'm listening to one song for 2 minutes, which is kind of the average for all users over that song. And let's say you decide to listen to it through the whole duration for 4 minutes, right?
Mhm.
So there's a bit of a like not an outlier per se, but there's a bit of a big delta there that would
Mhm.
entail and indicate maybe that you might like songs of that nature and you might like songs like that. So that's something I think we can definitely put into as one of our features as well.
Okay.
Um, but yeah, I think I'll pause there. I know I threw a lot of things. Is there anything else that I might have missed out on? Something that stood out to you?
I don't think so. I think that that's a really good, diverse array of features to start out with. Yeah.
Awesome.
Now that you have an idea though of like the features that you want to create, um, I think it'd be good to talk a little bit about the model. What kind of model would you want to use,
Mhm.
and why? Because I know there are many options out there.
Yeah, definitely. I think this is the more fun part of doing machine learning, right? Traditionally, at least, recommendation systems uh, take advantage of user data that you already have. So the idea is, imagine you're living on a house in a neighborhood, and if you are similar to multiple different houses in that neighborhood, someone might take the liked things from the other houses and recommend that to you. And that's similar to what we
Yeah.
call what a collaborative filtering model is.
Mhm.
And so we're going to try to experiment with something here. So if you have existing users and have existing user data, you can kind of take that advantage of that data and then basically use that to recommend something to a new user. There's
Mhm.
also the concept of content filtering, where you're not necessarily looking at user data, but you're looking at your entire repository of items that you have.
Mhm.
And based on just the user's history, the user that you're recommending to, you're going to see a compatibility score of that user's history with all of the items that you have and see whichever one has the highest compatibility score. And you can kind of recommend those and say, hey, you haven't seen this one, but I think you may like this. A lot of Netflix and Amazon and Airbnb, like a lot of these companies generally use those traditional systems to try to build more personalized systems. And like you said, there's many more, but obviously for the sake of time, I think the best thing to start off here is kind of looking at the collaborative filtering approach.
Mhm.
My assumption here is that we have enough user data to avoid what we call the cold start problem, which is
Mhm.
basically the idea that you have no data at all. What do I recommend to begin with, right? Because both of
Mhm.
these systems, collaborative and content filtering algorithms, they do require some kind of initial data for them to kick off. So in
Yeah.
those situations, you can kind of think about what are the top trending songs, top trending artists that everybody likes, and to sort of start recommending with those, and then start collecting click data from the user, and then
Mhm.
start tweaking your algorithm a little bit, because now your algorithm has a little bit of data based on what you provided to your user.
Mhm.
Does that kind of make sense? I'll pause there a little bit if you have any questions.
Yeah, I like that you were talking about the two different types of recommendation algorithms there. When you were explaining content filtering, you mentioned that there's a compatibility score that's used. Are you saying that that score describes how similar the items are that you might recommend to the items that the user has viewed or listened to previously?
Yes, that's exactly what it is. So a simple example might be, if you think about Netflix, right? Let's say you're watching Iron Man 1, and you know that these are
Mhm.
the actors in Iron Man 1, you know the genre that it falls under. And let's say you watch the whole movie, so they have play history time with it. So
Mhm.
you'll use that data to say, okay, the best score here, if you look at Iron Man 2, Iron Man 3, Captain America. And then let's say the fourth movie is Independence Day, right?
Mhm.
The compatibility score with Iron Man 2 and 3 would be a lot higher
Mhm.
than with Independence Day because
Mhm.
of similar features that are there.
Mhm.
Obviously, mathematically, there's a lot of work that's done to kind of create that compatibility score, but that's essentially what I was going for. And so I would
Okay.
recommend Iron Man 2 and 3 as like good matches.
Gotcha. Okay. And one more thing I'm curious about is you decided on using a collaborative approach. Why that one instead of content filtering?
Yeah. So my assumption, I guess, with this was that we have enough content or data on existing historical users that we can take advantage of. Existing historical user data tends to be more dynamic and more fast changing than data that is more on the items in Spotify, right? So these items tend to move around a little bit, but not as frequently as user data, because you're constantly getting that data. And because of the dynamic nature of it, I believe that the accuracy will be a lot higher, will be a lot more precise. So when in doubt and I have a choice, if I have the data available, I wanted to kind of lean towards using collaborative filtering over content.
Mm, because that's like a richer source of data, right? The user data.
Exactly. Yeah.
Yeah.
The other thing I
Mm,
wanted to also add in is that music is something personal. A lot of it is
mm,
very much where, people recommend one thing over the other, right? People, generally,
yeah.
your friends want to listen to what you recommend them, right? Over,
Mm,
a machine recommending it. So if we're
yeah.
able to harness that by using collaborative filtering, I think we'll be able to sort of replicate the same thing and have a better success rate.
Okay. Perfect. Thanks so much. Okay. Yeah. So keep on telling us about, yeah, please continue telling us about this model.
Yeah. So we talked a little bit about the choice of the model and why we kind of chose it. The other thing I wanted to mention is sort of thinking a little bit about how collaborative filtering works. I mentioned a little bit around the scoring aspect of it, and that's kind of exactly what you're doing in this scenario. You use something called a user item matrix, and then basically what you're doing is essentially finding kind of a cross join between the item that you're recommending as a column, and then each user is going to be a row, and you're going to essentially calculate a product at each point to see how close that number is to one or how close it is to -1. Closer it is to one, the better of a recommendation it is. Closer it is to -1, the worse of a recommendation it is. And you do this over and over again as you get more data. And then as your feature vector keeps growing, you're going to do more of those. So there's some pitfalls that you'd want to kind of think about here from a technological standpoint, but we'll get to that in a little bit later.
Mhm. Okay. Sounds good. Um, all right. So now we have our features in our model. What else do you think you would need to worry about?
Yeah, I think the next thing is really thinking along the lines of implementing this and understanding a little bit on when we put it into production, what are some things we want to consider, right? This can be things such as compute and storage resources that we would need to sort of train the algorithm every single
Mhm.
day, or in our case, it's a batch-based system. So do we want to train on an hourly basis, a couple of hours, every 24 hours? What's that cadence going to look like? And then there's also the testing validation piece of it. So we want to make
Mhm.
sure that, whatever we're training out and then we're actually running tests on it, is the accuracy that we see during the training, is that matching the test accuracy? And then when we put it into production, what is that accuracy looking like, right? At the end of the day, the whole point is to ensure that whatever we're putting into production is hitting that metric we're looking at, and we're
Yeah.
essentially trying to push that. So you want to think about things like that, where how well is my model doing compared to maybe a randomly chosen set of items that we're
Mhm.
showing a particular user. And when you do those kind of baseline comparisons, you're going to try to understand if your model is doing well, it's doing worse,
Mhm.
what can we tweak, etc. From a compute standpoint, cloud systems like AWS have made life a lot easier, right?
Mhm.
Take advantage of tools like AWS SageMaker to house your model, containerize it, train, test, all of that. Think about serverless systems like Lambda, right? How is this going to
Mhm.
interface with your product? So you have a
Mhm.
product and a user logs in, or a user opens the app. Asynchronously, it sends an API request to your service endpoint, and the service endpoint might fetch the latest recommendations for that logged in user and serve that to the user. So
Mhm.
there's a lot of little moving pieces and parts that are kind of there. So those are sort of the things that you think about.
Mhm.
And the last thing is thinking about scale, right? So
Mhm.
let's say you have, for the sake of argument, 100 users today at the sixth hour at 6 a.m., for example. But let's say tomorrow at 6 a.m., the same time, it
Mhm.
scales to 200,000 users. How is
Mhm.
your service going to handle that traffic, right?
Mhm.
Do we put in some sort of auto scaling system? Even if we do, how is that going to affect my model? Is my model going to be able to churn out those numbers that quickly? So those are kind of the things that you want to think about after the whole model and feature engineering piece is completed.
Okay, gotcha. Yeah, so how about let's talk about a couple of those things. So one of them being that we've talked a little bit about metrics and how like engagement is ultimately the metric that we're trying to optimize for. Is there anything else that you would try to measure, like either before or after deploying this model?
In terms of the success of the model itself.
Yeah.
Okay, so engagement is one thing.
Mhm.
I think the other thing that I would probably look at is, it's one thing to click a product that we're kind of giving them, right?
Mhm.
The other thing is also kind of thinking along the lines of, I mean, are they listening to the song fully, or are they listening to it partially? Based on that, are there further interactions going on with similar kind of data that they have?
Mhm.
So this is more kind of thinking about the extent of the engagement that's happening, or is the user churning, right? So if let's say I'm giving 10 recommendations and the user clicks on 8 of them, that's a pretty good like engagement rate as per our metric. That's 80%. But if they're listening to it, each song, let's say each song is about 4 minutes for the sake of argument. If they're listening to only a minute of it, or they're barely listening to it before going on to the next thing, has our model really been successful? Because that could lead to the user just, kind of churning eventually because they know 8 out of 10 songs were okay, but not really something that they like. So I would say maybe definitely look at long-term churn. So maybe 7-day churn, 14-day churn, things like that. And that combined with our engagement metric will really give us like that strong indicator of, yeah, we're doing a good job and this is a good recommendation system.
Yeah, I like the underlying concept of how we're measuring these metrics over time, right? Because the performance of
Mhm.
our model may change. What is like another way to segment out the engagement metrics to better understand where our model does well or doesn't?
Yeah. So is your question primarily focused on like I guess features for that matter? So we're looking at like demographics, age group, like segmenting on that sort of metric and then figuring out where it would do better. Is that what you're going for?
Yeah, those are all possible things to segment on. And for example, like newer users versus longer time users, right? It's possible that the recommendations are more effective for the longer term
Mm,
users than for new users. Yeah.
yeah, yeah,
Or
definitely. Yeah, I
perhaps
think.
for, yeah,
Go ahead.
or perhaps for users from like one country over another. Yeah.
Hmm.
Mhm.
Yeah, geographical setting, age groups, gender, all of that definitely makes a difference. Even kind of looking at follower to follower ratio between different artists and kind of taking that into account to try to see how that affects our engagement and our churn also makes a big difference. I like what you mentioned a lot about looking at long-term users versus new users, because again, that's the kind of goes back to that cold start problem that the traditional recommendation system algorithms have a difficult time solving. But maybe looking at something different, like a decision tree or an XGBoost, or even like some kind of deep net, might help kind of solve those and fill in those gaps, right? And this could be further iterations as we look into kind of scaling this up and we see some success with our first result.
Yeah, exactly. And like tracking all of these like more metric breakdowns rather than just the aggregate metrics can help us have
Exactly.
those insights, right? Yeah.
Yeah.
So I'm curious then, like, let's say, okay, you've deployed your model, it works pretty well, and you're
Mhm.
tracking it over time, and suddenly you're noticing like a little bit of a regression. How do you decide when that you should like update your model?
That's a good question. Um, and I feel like a lot of this is very much kind of a art more than a science, right? I
Yeah,
think
it is.
as your intuition sort of develops over working with this, you start kind of getting more into knowing like this is sort of the right time. And I think this
Mhm.
is one of the more things about ML that's like different from other types of software, is that there's always a lot more post production work where you're constantly experimenting and constantly seeing like what's going
Mhm.
on. Generally, my suggestion would be to have some sort of benchmark before you push it into production and see how
Mhm.
the benchmark is doing in comparison to the model that's in production. So let's say we have our collaborative filtering algorithm that's running, and then let's say our second closest model that could have taken that spot is an XGBoost, right?
Mhm.
And so everything's working fine with the collaborative filtering algorithm, and all of a sudden the regression happens, and you start seeing a decrease in model performance.
Mhm.
You can immediately you can keep testing the XGBoost model in parallel, and if you do see
Mhm.
that there's a small spike in the increase of performance of
Yeah.
the XGBoost as new data is coming in, then
Uh-huh.
that's kind of a clear indication right there that the
Yeah.
XGBoost might be a better switch out. So
Yeah.
having the possibility to switch that out might be a good thing. It's possible also, it's good to also check in like things like overfitting to see that as this retraining keeps going on, are we suddenly starting to overfit? Are we know our data too much in training that it starts to overfit? And when that happens, that could also be a bit of an indicator that, in production, it's not doing as great, but our training validation and training accuracy might be abnormally high, right? If you're getting a 99% accuracy in training, but you're getting a
Right.
70% accuracy in testing, that something's wrong. So
Yeah, exactly. Yeah. And it seems like you mentioned two different axes of like things that you might change if you need to like refresh the model that's in production, right? You mentioned like the type of the model and also the freshness of the data, right? So it's nice that you have this benchmark way to compare both of those factors.
Yeah, and most
Yeah.
importantly, with the same data that's coming in. So you're kind of like
Yeah.
comparing apples to apples to see two different models and how they do with the same
Mhm.
data.
Yeah. Mhm. Yeah. Okay, perfect. Any last thoughts before we get into some interview analysis?
Um, yeah, no, I think we've covered the at least the initial life cycle for the most part of
Mhm.
it. So I think that was everything.
Yeah, definitely. Okay, thank you so much. I'd love to hear from you. What do you think went well about this interview, and what do you think like you might change?
Yeah, I think things that went well. I think the assumptions part in the beginning and like also throughout the part where we were talking, we were making certain surefire assumptions that allowed us to kind of concentrate on how to build like the simplest version of the model. I think there's a lot of focus on kind of figuring out how do we build like the most MVP basic iteration, which went well. The second piece is I think we comprehensively sort of went through each of the ML lifecycle process, right? We analyzed our problem, we analyzed our metric, we thought about, what are some of the features that we would need to produce and how do we get these features to happen? What kind of data processing we would need to do to produce these features? And we talked a little bit about analyzing models. So we sort of went through a very high level, quick way of kind of getting from point A to build a model and get that model into production. So we have a game plan. I think what I personally could have improved on is maybe sort of shortening, I guess my spiel and like sort of getting to the point a little bit quicker. I think that was definitely something that I could have improved on, and I think we could have done a little. I could have done a little bit better on the actual production part of it. So we mentioned a little bit around different tools we can use to productionize our model. I think we could have done a little bit better on like sort of drawing it out and see how that flow would look like, and see like how the interactions would happen between the model, the application, storage systems, and things like that. So yeah.
Mhm. Yeah, it could be really helpful to have like that visual schematic of like exactly what inputs are going into each component and how do the components connect to each other and so on. Yeah, definitely
Hmm.
agree with that. Yeah, I totally agree though. You did so much so well. I really appreciated the level of detail that you use in asking clarification questions in the beginning, especially about the data. You made sure you knew exactly what your data sources were and like what formats they were in, and I think that made like the pre-processing part of your data pipeline like very clear and polished.
Hmm.
Yeah, and I also like that you talked a lot about trade-offs for everything. Basically, you talked about like trade-offs for batching versus real time, and you talked about the trade-offs for like different types of recommendation algorithms. And ultimately, that is like one of the most important things to do in a machine learning system interview, right? Because there's not like a strictly correct answer. It's mostly just about how can you justify your answer. So I really appreciated that about your answer.
Yeah.
Um, yeah, I would have loved to hear a little bit more about. I think you talked a little bit about the collaborative recommendation algorithm, but I didn't hear much about like how are we actually filling in this user item matrix, right? There's so many different
Mm.
ways that you could possibly do it. You could give like a high level summary of like some of those ways, or you could just pick one and explain like how it works, why you picked it, and so on. I think either of those approaches is okay.
Okay.
Yeah, how does that all sound to you?
Yeah, sounds great. I think that's really good feedback to take in for sure.
All right. Thank you so much today for sharing all of your knowledge about this. I think we've learned a lot from you. And thanks everybody for watching and good luck on any upcoming interviews that you have. All right. Bye everyone.